Hello everyone, so we are going to do knapsack today. What exactly is a knapsack? Knapsack consists of a knapsack that has a certain weight. In our case, this is represented by W, which has the weight 50, and you also have certain weights of 10, 20, 30 that right now is stored in this array, and these weights have associated certain values to it. So again, that those are inside the array. So the problem says that we have to fill this knapsack such that our value, the total value, is maximized. So we have to fill this particular knapsack with these weights such that this value is maximized. Again, this is very common dynamic programming problem, so you can Google about it. But for now, we will be starting it with the recursive solution first, and then using that recursive solution, we will be building a dynamic programming solution. So let's see how this particular problem can be solved with a recursive problem. So func, I'll start recursive knapsack, and whatever these values that are provided, I'll just use them as the parameter to this particular function. So first is W, another one is val array, and again W is an int, val comma wt are two arrays. Right, apart from that, so what will be a recursive solution for that? So at every point we are going to make a choice that whether to select that particular weight or not, and that choice will be based on first whether that weight is less than this particular weight or the capacity of the knapsack, and again we are going to maximize our value. So first let's see what will be the base case. So if our weight is 0, right, that is done. And another thing is we are going to iterate over these arrays, so we also will be requiring one index to do that. So let's call it n. So if either w equals to 0 or n equals to 0, that means we do not have anything, then we just simply return 0. That's our base case, and add the return type here in recursive knapsack. So now next thing is, as I told, we have the choice is based on the weight. So suppose our wt for any weight n is less than equals to w, then that means that that particular weight can be selected. So let's see. So if we are going to select that particular weight, so we will use its value, the val of n plus what you are going to do. Since we have selected it, we will recurse with now w comma n. Now the remaining weight will be w minus wt of n, and we will select next element. The rest are the constant values. Right, so this is one thing, but we can either select that one. So this one is for selecting the weight, or we can also not select it. Right, and in that one what we have to do, we have to maximize the value. Right, so either select that, max of either select that, or we are not going. In case we are not going to select it, then our weight will be still that. We now move to the next element, and the rest of the parameters are just the constant. I'll quickly write this max func of max. It takes a comma b, and it returns whatever is the max. If a is greater than b, you simply return a, else you return b. So simple. Right, another thing is now else that means that your weight is now greater than W. That means that you are not going to select it. In case you are not going to select it, that is our second parameter of the max, right? And just close this. So this is our simple recursive knapsack solution would look like. So also just call this method here. W comma n will be this len of val -1 val comma wt. Right, so this is our recursive solution. Just I will be quickly running this. Let me clear this everything here. So quickly just run it, and our solution, oh, we haven't printed it, so let's print this. Yeah, so our max value that can be inserted inside this knapsack with max weight as 50 is 220. Right, so this is our very naive recursive solution, but there is scope of caching few of these values because there are overlapping sub problems here. For instance, for any weight wi and n-1, this can be solved here also, and here also. So what we will do, we'll create a cache, cache. That will be a simple map, and let's take it as a string, its value, and it's stored that whatever value, maximized value that can be stored. So here what I will do, I'll check whether that particular weight and n is already available in the cache, right? This is the only parameter. These are the two parameters that are changing amongst these calls. Rest of these things are constant. So we'll see whether for these particular group of values, let's say this is I, this is j, whether recursive knapsack has already solved it. So let's say key value, it's available inside the cache. So right now I have used a cache, but I'll use a scalar key. So for that I'll just do %s dot %d, or both are integers, so I'll just use w comma I n. Right, so if this is already solved, that means my answer is already there, so no need to recurse again. Okay, if I'm not required. And here, instead of directly calling it, I will also cache it. So I'll just save it here. So cache of this will be calculated value, and that's it. Yeah, this may be calculated here also, so I will also save it here in case this gets calculated here, and again same thing. Now our recursive solution is a bit faster. Also return this. Yeah, let's try this and see whether we are getting 220 right. So what happened here, what we have done is, instead of solving for a particular inputs or a pair of inputs w and n, or I comma j, multiple times here we just cache this solution, and anytime we see that for this particular pair, if that problem is already solved and its solution is stored in the cache, we just return the solution. So this is as good as any dynamic programming solution as well. We will also see a top-down approach in our next video.